Hello. As at the time of this recording, we are third year mathematics students of the Kwame Nkrumah University of Science and Technology. And I am Anna Couette.
I'm Mr. Said and Set.
I'm maybe they do Donko.
And I'm Champa Boating Dennis.
I'm Poiseulle.
This is a video on the parallel viscous flow, demonstrating Couette flow, Poiseulle flow, and the mixed flow.
So in this type of viscous flow, we are going to use this as our parallel plates. This being the upper plate, which moves during the Couette flow, and then these two being the fixed plate. So this is the lower plate, then this is the upper plate. Now, in this type of flow, we are going to regard this as our input or inlet, and then this is going to be our outlet. So the liquid or the fluid is going to be placed through this plate and then demonstrate the type of flow depending on the boundary conditions that are placed on this.
We begin with the Poiseulle flow where both plates are fixed and we are using the viscous fluid sanitizer. Since this phenomenon is pressure driven, we induce pressure by increasing the amount of fluid being used, which causes the movement of the sanitizer. As seen, the mass was increased to induce the pressure, and this causes a bell shape which is known as the Poiseulle flow.
So this is better explained by this simulation here. We could see that the velocity changed from yellow to red, which means that at the end of the outlet the velocity increases, and then at the walls, because of the no slip condition, you can see that the velocity at the walls are very minimum.
Up next is the Couette flow. In this phenomenon, the fluid flows by the movement of the upper wall, and the mass is constant. As you can see, the flow of the fluid is being caused by the dragging of the upper plate, and this forms a right angle triangle shape.
So the simulation here tells us how exactly the movement is. For the Couette flow, you could see that the movement of the layers is linear, and you could also see that because of the no slip condition, the walls at the lower plate, the velocity at the lower plate is blue, which is making it zero.
Lastly, we are demonstrating the mixed flow, which is basically the combination of the Poiseulle flow and the Couette flow, where the flow is caused by both the pressure gradient and then the movement of the wall.
Now the simulation here also tells us more about the velocity of the fluid. So you realize that since the upper plate is also moving as well, the fluid at the walls of the upper plate is also moving perfectly. But then with the one at the lower plate, you could see that the fluid there moves with a very small velocity, which is not actually blue but green. So here are the graphs of the various parallel viscous flows that we have, and they have their counter maps below them. Thank you.